Alright, so now let's translate our air particles into some displacement distance graph. Okay, so first thing, how do I translate the movement of the particles on the graph, right? So of course, we start off with the compression and rarefaction, because we know that for compression and rarefaction, the displacement from the EQM is actually zero. So you can see, right, for the yellow shaded region and the green color shaded region, they are all known as your compression and rarefaction. So of course, I just label them first. Okay, so for the compression, the first compression is right here. Then after that, for rarefaction, the green color rarefaction. Then the next will be compression. Then next will be known as your rarefaction right here. Then next will be compression. So rarefaction. Then last but not least will be a compression. So you can see, right, all the compression and rarefaction, they will be at the zero equilibrium position. Alright, so let me just shade first. Okay, next will be the labeling of the amplitude. So you can see that they are color coded by the purple color, right? Okay, so if you look at before sound and after sound, right? So no sound. So no sound, you're at the EQM. So after sound, the particle, right, will actually move. The very first particle will be moving towards the left hand side. Okay, so maybe let's denote some direction problem, because we know that displacement actually is a vector quantity. So the direction actually is very important. So okay, let's for simplicity's sake, I denote right hand side to be positive, left hand side to be negative. Okay, so you can see that for the very first particle, right, first purple particle right here, it actually moved towards the left hand side. So I must put at the negative region of the graph. So this will be the very first particle. Okay, then you look at the second particle right here, right? Okay, so this second particle actually moved towards the right hand side. So looking towards the right hand side of the EQM. So I will label right here. Okay, so after that, of course, for the right hand side, just remember must be in the positive region of the graph. Then for the next particle, which is I call the third particle right here, is moving towards the left hand side. So I just label here. Okay. Okay. After that, the fourth particle right here, so it's moving towards the right hand side, right? So I label in the positive region of the graph. Okay, after that, the fifth particle is moving towards the left. I will label in the negative region of the graph. The last particle, the sixth particle right here, I will label on the positive, because it's moving towards the right hand side. So I just label right here. Okay. Yeah. So after you label, right, you can see that it's roughly a sine graph or negative sine graph. So you just need to connect the dots. So for example, you just connect like that. Draw something like a sine graph. Okay, something like that. Okay. Yeah, so this is a sine graph. Always remember, for physics, right, when you are given a graph, the positive and negative region just indicate the direction. So for example, if you are looking at this region of the graph, right, so positive, positive, positive just means that the particles are moving towards the right hand side. Then of course, for the negative region of the graph, right here, right here, right here, right, so you are actually moving towards the left hand side from the EQM. Right, so I hope this clears things up.